I'm Anil Kumar sharing a question from my student Ryan. The question here is based on inverse of a function. We are given f of x equals to x squared plus 3x minus 3 and g of x equals to f inverse of x. Find possible values of g of 1. That's the question for you. You can pause the video, answer the question, and then look into my suggestion. Ryan, first let me thank you for such an excellent question, and I hope that the other subscribers will definitely benefit from its solution. Let's go through this question once again. It says, given f of x equals to x squared plus 3x minus 3 and g of x is inverse of this function, right? Find possible values of g of 1. So let's begin by saying that let g of 1 be equals to a, right? Now what does that mean? G of 1 is a, that means the coordinate point we are looking for is 1a, and this coordinate point is on g of x, right? Or f inverse of x, right? So that means 1a is a coordinate point on f inverse of x. So what will be corresponding point on f of x? Can you tell me that? It is inverse function. So on inverse of inverse we'll have a1, right? So on f of x, a1 will exist. So that really means that f of a equals to 1. So we know what f of x is. F of x is equals to x squared plus 3x minus 3. F of a is 1, so we can replace x with 1, x with a, and that will be f of a, which is 1. So we can now write f of a is equals to a squared plus 3a minus 3. Since f of a is 1, that should be equal to 1, right? So we can now rearrange and find the value of a. So what we get here is a squared plus 3a minus 3. Bringing it to the left side, we get minus 1 equals to 0. Or a squared plus 3a minus 4 equals to 0. It could be factored as a plus 4 times a minus 1. 4 minus 1, 4 times minus 1 is minus 4, and when you add that, you get 3, right? Equals to 0. And that gives us two values of a. So a could be minus 4, or a could be equal to 1, right? So the g of 1 can have either minus 4 or plus 1 as the values. So our answer is g of 1 is equals to minus 4 and or 1, right? So both values it could have. I'm Anil Kumar, and I hope that helps. Thank you and all the best.